Good morning, everyone, and welcome to another day of notes for physical science. Glad to have you here. Let's dive right into it. Today, we're talking all about work. So, the goal for today's lesson is to, again, kind of talk about what is work. This should be a review, and then we're going to just hop right into working with some work equations. So, very excited for this. I hope you are too. Let's get into it. So last time I showed you this Venn diagram of work versus energy, and one of the main things I wanted to point out is that work has a different formula than kinetic energy or potential energy, but they both have the same units. They both use the units of joules. And then we also said that for work, joules come from combining a Newton and a meter, multiplying those two together. That's how you get the unit joules. Whereas in kinetic energy and potential energy, they come from some combination of kilograms, meters squared, and seconds. Fun fact, a Newton itself is actually a kilogram times a meter divided by seconds squared. Because remember, Newtons is force, and force is mass times acceleration. So mass, kilograms, acceleration, meters divided by seconds squared. That's kind of where we get the Newton from. And then when you multiply meters by newtons, you get kilograms times meters squared divided by seconds squared. And that's a joule. Works the application of force over a distance. Energy is the ability to apply a force over a distance. And then also lastly, work is a change in energy. So in order to give something a new energy state, you have to apply work to that object. Great. Okay, so here's a question that we have for you, and we're going to use the formula work equals force times distance. So the question is, how much work does Ned do when he lifts a box from the ground to a height of 1.5 meters while exerting a force of 200 newtons? So in this case, we could say that the box weighs 200 newtons, and it would have a mass in kilograms, but that's not necessarily super important. For right now, all we have to do is take this force here and multiply it by distance. And that's W equals FD. So there I am kind of showing you as we work through how the units all work out. So we get joules as kilograms times meters squared divided by seconds. That's not super important. You just have to write joules at the end of your problems. Awesome. Okay, so here's our formula. Work equals force times distance. I've got force in green, distance in blue. So our distance is going to be that 1.5 meters, while our force is going to be 200 newtons. So plug those into the equation. We're going to get 200 times 1.5, and that's going to give us an answer of 300. And then notice how I included a little j there for joules. So that's a really straightforward problem. Not a whole lot to do here other than set up the equation and plug in numbers. As we move forward here, we're going to add a little bit more complexity to these problems. Here's a question about John riding his bike. He applies brakes, and it says the force of kinetic friction in the brakes is 100 newtons. How much work does John's brakes do if he stops in 10 meters? Here's what I want you to do, guys. I want you to try this problem out on your own. Pause the video, try it out, and then we'll go over the answers together. Okay, hopefully you're ready to go over the answers. Here we are. Once again, work equals force times distance. Force in green, distance in blue. Our force this time is 100 newtons, and our distance is 10 meters. So we're going to take 100 times 10, and we get 1,000 joules. Great. Let me know if you have any questions on this. Send me an email. Sound good? Okay, so there's one other way we'll ask you work-related questions, and that's if we're lifting an object. So let's take a look at this problem here. It says, if an object has a mass, we can figure out the force required to lift it. Remember, force is the same thing as weight. And back in Unit 8, we talked about weight's definition, which is the acceleration due to gravity times mass. So force is really acceleration due to gravity, which is g times m, mass. Now, if you remember, acceleration due to gravity has a specific number. And that number is always 9.8. The number is 9.8 meters per second squared, or just 9.8. So anytime we're talking about a force, but we just give you the object's mass. To figure out what that force is, you just take the object's mass and multiply 9.8 by it. Now, we can substitute this 9.8 times m into our work equals force times distance equation. So that's what we're going to do. And then instead of it just being F times d, now the equation is 9.8 times m times d. Pretty cool, huh? Great, so let's use that on a problem. This question is, how much work is required to lift a 10-kilogram child from the ground to a height of 1.5 meters? So here you'll notice that I set it up with work equals 9.8 times meters, or times mass times distance. So in this case, what we're going to do is we're going to plug in that mass of 10 and plug in that distance of 1.5. And when we do that, we get 147 joules for our answer there. All right. Well, hey guys, thank you so much for watching this video. Hope you guys learned a lot about work. And if you have any questions, as always, let me know. Here to help. Thanks. Have a great day.